Alright guys, so I have simplified the Silver Pulser even farther. Now he only uses one 30-volt power supply. This is 400 milliamp 30 volt. This is one of the most expensive component in this setup. Cost about $10. And then we have one PWM. This component, if you buy it from China, it's like a couple dollars, and if you buy it from US, it's about $5. Altogether is about $20 with the shipping. This is 60 cents. It's a 5 watt 18-volt Zener, and then relay like $1.50 or something. And this light is also like 50 cents, and this is $1 or something. So one, two, three, four components and two modules. PWM, pulse width modulator, and power supply. And you can say also this setup, being simple as is, it's got a protection, so in case you short your electrodes on the output, and nothing will happen. The light will go on and will take all the load in itself, and your potentiometer not gonna burn. Without this light, this can damage your potentiometer if you crank it up all the way and shorted the pins here. So let me plug it in and we'll take a look on an oscilloscope. I have my scope connected, so here we go. It operates now, and this is the output from it. Currently I have connected one resistor. This imitates resistance of the skin, so I don't have it connected to my hand. It's similar, it's same thing. And let me show you the power adjustment, voltage adjustment actually. So with this is, if you, as you turn it down, you will see, look at the oscilloscope, you'll see the output is being adjusted, and as you crank it up, the output will increase more and more to the max. And max is 30 volts on and 30 volts off. So it switches between positive and negative. This is the off line. Basically, if I turn it off, it will end up to be here. And so it switches on for quarter of the second, and on for quarter of the second. So this PWM has got a couple adjustments. When you get it, it's not going to be pulsating at this speed. You have a few pins here you can adjust. So you place your connector, this thing, on the very edge, 2 pins, and on this right potentiometer, what you do, you adjust it all the way to the clockwise, all the way to the right, until your light, sorry about that, is, let me turn it, turns on solid red. And then you go back a little bit. This will make it so that your duties on and off are close to 50%, more like 45 and 65%. You see that it's off for a little longer than it's on, but that's not a big deal, it's fine. In our scenario, we just want to make sure that for close amount of time it's off, and for close amount of time it's on. Then on this second variable resistor, you can adjust the speed. So if you turn it to the right, you will increase pulsation. You see how much faster it pulsates, and you can see that speed is increasing. And then if I turn it to the left, I can decrease the pulsation speed. And so you're gonna have to manually adjust to about 4 times a second pulsation. So that's the only adjustment you're gonna have to do to make it work properly. Then another thing is your electrodes. You can use, I got from the Sota Instruments the original one. These are the silver ones, but you can use like stainless steel, for example 316L or H grade, and those would work just fine. And these pouches, I believe you can buy them online separately. They're like replacement pouches. So if you Google Sota Silver Pulser, you know, these pouches, whatever, I don't know how they call it, but anyway, I'm sure you can find them. And this is like a Velcro strap, which these pouches are attached to. They can stay on a certain distance, right over the veins. You place them over the veins. You're gonna need to prepare a water solution. This has a couple pinches of salt in it, so that you'll make it more conductive. And then you spray on it, and you place your electrodes inside of these pouches, and then you place this over your wrist, over the veins. So that's there. This is the electronic circuit for this setup. It's very simple. I haven't had a time to put it on the computer in a computer format, but that's something I'm gonna go ahead and do soon. And I am preparing the parts list so that you can go to one of the sites like digikey.com and get everything you need to complete this project. Also, if you guys are interested to add one more feature to here in to make a colloidal water, as silver pulsars are able to do it, I'm gonna have to add one more switch to here, toggle switch, and you will be able to use that 30 volt that's coming from this power supply wall adapter and make a colloidal water with it. So let me show you how protection system works. Let me crank it up all the way. So let's say you had it all the way, which normally you probably wouldn't because it's pretty intensive, and then you end up shorting these two terminals. So I'll go ahead and short them, and you'll see the light will come up. You see the light will coming up. So that's your protection in case you end up shorting these two terminals. Your variable resistor is not gonna get burned. Well, that's about it, guys. Let me know if you want me to add a switch to make it more to make it for colloidal water, and I'll go ahead and add that onto the circuit, and we'll add that to parts list as well. That's about it. If you like the video, give me a thumbs up, subscribe, and I'll see you in the next one. Let me show you a close up of this setup here. For those of you who would like to just assemble it in air like I did, this took me like 10 minutes and I built the whole pulsar in 10 minutes. What I'm also thinking is to design a printed circuit board for it. So all you're gonna have to do is pop your components into the board, which will have labels for every component, and solder them. You'll make it even more simpler. So you can't get simpler than that. This is the simplest setup ever. It just cannot get any more simpler. I specially designed that for you guys so that most of you would be able to build this project. Okay, if you like the video, give me a thumbs up, subscribe, and I'll see you in the next one.